correlations. In the previous video, we looked at how to come up with a scatter diagram here in the correlations, and we said that the word correlation simply means the relationship that is existing between two variables, which we call bivariates. Okay. So next, after knowing how to draw the scatter diagram, so today we are going to see how can we draw the line of best fit. Okay, this is what we are going to look at. So what is the line of best fit? This is the line drawn through. This is a line drawn through the points. Plotted on the scatter diagram. Okay, so this line here, this line which you're calling the line of best fit, this line passes through a point, x bar, y bar. Because we are talking about bivariates, then we must have two variables, variable x and variable y. So x bar, because we are saying that this line passes through the point this and passes closely, okay, to each of the plotted points, Okay, so that is about the line of best fit. Perhaps we can know where x bar, this is equal to summation x all over n, and y bar is equal to summation of y all over n. Okay, so how does it look like if we are to draw our line? If this was previously our scatter diagram, okay, that is our scatter diagram previously, like this, with the points running like that. Previously, that was our scatter diagram. So we are required to now draw the line of best fit. We are saying that a line of best fit is a line that has to pass through this point here, x bar, y bar, and it must pass closely to each of the plotted points, that is x bar, to each of the plotted points here on the scatter diagram. Okay, now after getting your x bar, this is now our mean point, because we can see that to get x bar, we shall take the average or the mean of all the points in the x column or row. To get y bar, we shall have to get the average of the numbers which are provided to us in the y column or the y row. So we have here x bar, y bar. So having gotten this point here, we shall plot it on our scatter diagram. If previously you had used stars for those other ordinary points, now when you have to plot this other point, which is the main point, you just have to use another from this rest of the plotted points here. So after identifying your main point, capital M, which is x bar, y bar here, we are now going to draw our line using a ruler. So how do you draw it? How do you draw the line of best fit? If this is your scatter diagram and this is your main point, you just get a ruler. Okay, get a ruler, then you place it and while passing through this point here, then you count points which are this side should actually be equivalent to points which are this other side. Here you notice that the line of best fit may not necessarily pass through these plotted points, but it has to pass closely to them. So what does that mean? Let me have my line. If my line goes like that, pass it through that, pass it through that, okay. Uh, this is my line, pass it through that, there, passes there. This is my straight line. And now what we have done here, this is our line of best fit. Let's check this and see here. Up here we have 4 points, and down here we also have 4 points. Now if points have to be greater, if points on the two sides have, if points which are on one side have to be greater than the points on the other side, then the difference in the number of those points should actually be 1. Have a note down here in the next slide. Have a note. Line of best fit is drawn in such a way that the line of best fit is drawn in such a way that it passes through the points, or divides the points equally, or divides the points equally. Okay, then you are saying that the line of best fit is used to estimate. Now this is how we use the line of best fit. The line of this one of how we draw the line of best fit, we have already seen it in slide 1. So how can we use this line of best fit? So this line of best fit is used in predicting or estimating the future. There we are. Now what follows next is an example. An example follows there. So my example is here. Our example is there. The table below shows the percentages of sand Y in the soil of different depths x centimeters. Here we have depth. Here we have depth, and here we have percentage of sand. Like if you can recall from our past lesson, we say that this is an independent variable, and this other one is a dependent variable. Okay, now they need us to plot this data on the scatter diagram. Okay, that's the first question. Then after that, we state the type of correlation which the data displays. Of course, we shall state the type of correlation which the data displays basing on the trend which the points are taking. This is seen on the scatter diagram. And please be able to recall the types of correlation that we had in lesson 1. If you have not watched lesson 1, then please go and review it. Go and watch it such that you can be on track. Part B here, they now need us to draw the line of best fit through the points of the scatter diagram. This is what has brought us today here. Okay, now here is our graph. our scatter diagram is already here drawn for us. We have finished now drawing the scatter diagram. This is how it will look like. These points are taking now this direction. So if we are to comment about this type of relationship, you can see that these points are taking this trend. So what does this mean? This simply means that there is a negative between soil depth and percentage of sand Okay, now the next point is we have finished the answering now this. I've finished answering part A. Part A is done. Okay, we have represented our data here on the scatter diagram. We have gone ahead to state the type of correlation. The type of correlation here is a negative correlation. So if we made our comment here and said there is a negative correlation, this implicitly implies that there is a negative correlation. Okay, now we are going to the graph. Having plotted our scatter diagram here, we now need to draw the line of best fit. That's okay. Now before we draw the line of best fit, there are steps which we need to be taking. If you noted it very well, we say that to draw the line of best fit, that line there has to pass through a point x bar, y bar, and that line there should pass closely to each of the plotted points. Now, how do we get x bar? X bar here, this is just the average of, for example, x bar, if this is our independent variable, that means this is like our x. Yeah, indeed they have used here x. So to get x bar here, we're going to get x bar. X bar is got like, we have to get the average of all these points. X bar is going to be equal to, when you press on the calculator, we are going to have 52.1. This is approximately x bar. This is approximately 52. That is approximately 52. Then we do the same for y bar. We are going to add all these and take the average. In other words, you are going to take the average of all these points. So we have 86 plus we have 70. All of these divided by 10. So y bar, when you happen to press on your calculator, it is going to give you 78.9. 78.9. So when you approximate y bar, it is just the same as 79. So our main point x bar, y bar now becomes point 52.79. So we go to our graph, our scatter diagram, and we read where the point is. So we have a point 52.79 from our graph here. This is 10, 20, 30, 40, 50. So 52 is somewhere here, somewhere there. Then 79 is up here. Okay, so where do they meet? Around here. So up, you can see that these other points here have been drawn using, stars. Me, I'm going to note this one differently by using a dot and a circle, and this is my point 52.79. That's my mini point. So next I'm going to get a ruler, join drew the points. But we have, as we join those points, we have to put in mind this. We have to put in mind this note here that the line of best fit is drawn in such a way that it passes through the points or divides the points equally. So what does that mean? Let's go back to our graph. So if this, you can see that these points cannot be on the same line. Okay. Now we have to strive a way of drawing the line of best fit such that the points are divided into two. Okay, so I'm going to start drawing my line of best fit. If it passes through that one, no problem. There, and then it goes up from there. I have that. Okay, so that is my line of best fit. You can see I have 1, 2, 3, 4, 5 below the line, and I have up here 1, 2, 3, 4. So you can see that the difference in the points is just 1, and this is how we draw our line of best fit. Now on this graph here, after drawing our line of best fit, we can be asked a question like we have to use now our line of best fit to estimate some value. To estimate a value, they can say estimate the question. Another question can be added here that we estimate, because we say that the line of best fit is used to estimate or predict the values of the other variable. Okay, so that is what you are going to see next here. So they can ask us another question, that the value of y when x is equal to 50, when x is equal to 50. So we go to the x-axis here. X-axis, locate where 50 is. Locate where 50 is. Okay, so 50 is here. 50 is here. Then you get a ruler, and then you draw a straight line. You get a ruler, you draw a straight line. Get a ruler, you draw a straight line going up to the line, which you have drawn to there. Because that, observe that it has to be perpendicular. Then after that, move along across like that up to there. Then we are required to find the value of y. So what are we going to do here? We are going to read this value here after reading a 50 here on the x-axis. Okay, so that's what you are going to have for estimating the values. Now I think we are right to go to the exercise. So we are going to have these two numbers. We are going to have these two numbers. Please, you can take a screenshot, as you can pause your video, then you take a screenshot for those two numbers, and then we shall see one another in the next video. Please make sure you subscribe. Make sure you subscribe to my channel, because more videos will be loading. More videos will be loading in the mathematics at all levels and in the all topics. Thank you very much.